All right, now we're going to talk about section 7, or unit 7, section H2. That's honors 2, the law of cosines, and by the end of this, you should be able to understand it and use the law of cosines to solve problems with it. And like the law of sines, it is used with triangles that do not have right triangles in it. But unlike the law of sines, it uses two sides and one angle to solve those triangles. The law of sines uses two sides or two angles and one side. This uses two sides and one angle. And it goes off of again, you take something, you take a, you have a triangle labeled A, B, and C, and the opposite length of each instead of being labeled A and B, like the length here, like this length segment, instead of being labeled or known as AB, this length would be known as lowercase c, right? And this length would be known as lowercase b, right? And then this length would be known as lowercase a, right? But this thing goes off of, if we take we split C, not necessarily in the middle, but in a manner in which it comes down and makes a 90-degree angle, which is kind of hard here. Let's just say it bisects it. This is kind of hard to illustrate here. But let's say it comes down here and it makes a 90-degree angle. That's 90-degree angle because I said so. Okay, and we'll say that this new line segment here, this is x. And then what would this line segment be? Well, this would be c minus x, right? So this whole thing here, now we have a new triangle that will make this point D. Now we have two new triangles. We have ADC and we have BDC, right? And if we were to use Pythagorean's theorem, we would say that with length h here, say that this is length h, the hypotenuse being b for this one, and the hypotenuse being h or a for this one, we would say for a squared equals h squared plus c minus x. Actually, it'd be x minus, no, it's c minus x, okay. Yeah, c minus x quantity squared for this triangle. And then for this triangle, it would be b squared, because remember it's opposite the right angle. B squared would be h squared plus x squared. I'm using Pythagorean's theorem. Right? And the law of cosine is derived using Pythagorean's theorem, some trigonometry, and a series of and some algebra. But to figure out here, if we're going to solve for the cosine for each one of these triangles here, the cosine for each one of these angles, like the cosine of A and the cosine of B here, both involve h, right? Actually, they do not. Sorry. The cosine of the cosine of A here both involve x. So the cosine of A, cosine of cosine of B and cosine of A both involve x, right? So if we were going to solve for like the cosine of a here, cosine of a would be opposite over the hypotenuse, or sorry, correction, adjacent over the hypotenuse, right? It would be x over b, right? Sorry, that should be lowercase b over b, and the cosine of b would be c minus x over a. Right, they both have x in it. Right, and in order to solve for x, you'd have to do a series of algebraic manipulations, and then we would put them both equal to each other and do some algebraic comparisons and substitutions, and then you'd try to distribute them out, and then you'd notice some trigonomic properties and not properties, but laws that we haven't gone over, and then eventually you would come to an algebraic expression that would look something like this. It would be a squared equals b squared plus c squared minus 2bc times the cosine. Make that, I'm gonna make it bigger just to make it help you separate it, times the cosine of a. Okay, so I want you to notice the pattern here. The side that you're solving for and the angle are matched, and the two sides that you're multiplying and the two sides that you're squaring are matched. Right, so if you're solving for b squared, you're going to have a squared plus c squared minus 2ac times the cosine of b. Right, and if you're going c squared, like if you're trying to find the length of c here, it would be b squared plus, we'll just do it a squared, make it in the right order. It'd be a squared plus b squared minus 2ab times the cosine of c. Right, so those there are the laws of cosine. Laws of cosine. And I didn't go into a really in-depth explanation of the derivation, because I feared that it would just confuse you more, because it went over some trigonometric identities is what the word I was looking for, and that's not covered in the scope of this class in order to fully understand the derivation. And I didn't want you to get lost too much in the algebra, because this is what really matters, right? If you wanted to solve for any of these things, if you wanted to solve for a, right, you could just put, all this inside of a radical and just plug and chug it into your calculator, and you get the answer, right? It's going to come in like to some messy, it could come into some messy decimal or whatever, but that's okay, right? And just recognize the pattern of the equation, and it's not too difficult. right? It looks a lot like a Pythagorean's theorem, right? Um, but with this little stuff tacked on. Right? This comes from foiling out some stuff, right? The 2AB, right? The 2AC and the 2AB and the 2BC, right? And what is not included in here, like the variable, is over here, and that the angle associated with the length is tacked on at the end, right? So it's not too difficult to memorize. I hate to say memorize this stuff because you're gonna know how to like where the derivation comes, but that comes from pre-calculus and in a real trigonometry class. If we get into a full trigonometry class, so that'll have to come into the algebraic identities and stuff like that. All right, so let's go. I'll pause this to prepare a example of how to work these things, and I'll get right back to you. All right, so the question that was given to me is triangle DRP, D equals 10, line segment DP equaled 4.7, and triangle or measurement of angle RDP equals 60. Draw a triangle and label the stuff, and then we're going to solve for RP, and we're going to solve for measure of angle P. Okay, so we're trying to figure out this, and we're trying to figure out this. Okay, so this is D, line segment D. Okay, this is line segment R. Okay, and this is line segment P. I'll just use regular lowercase letters R. Okay, this is P. Okay, and let's see, is everything else done? All right, so now I can figure out what I need to. So I have two of the three lengths. All right, and I'm going to use the law of cosines to figure out the D here. Okay, so I can say that I need to use I'll use cosine of 1. All right, so I'll say that a squared, I'll say that this one, I'm going to say that d squared equals p squared, because I know p, plus f squared, because I know f, minus 2 times p, because I know p, and f, because I know f, times the cosine of d. Right, so that, see if that matches the pattern of one of these. Okay, so it's the front and the back, the first and the line segment associated with the angle, two line segments not associated with the angle, and those two sides squared. Okay, yep, that works. Okay, so I'm going to say that all inside of this okay, now I'm just going to plug some numbers in and figure out what D equals. Alright, so P is 100 plus 4.7 squared, 22.1. I'm going to round to the nearest tenth for this, I think. Yeah, I'll do the nearest hundredth. So I got 100 times, no, 10, sorry, oops, 10 times 4.7 times 2 is 94 times the cosine of 60 times 60 cosine equals 47 minus 47 minus 47. Okay, so now I can say that is 100 plus 22.09 minus 47. Take the square root of that. Distance equals about 8.67. Okay, that makes sense, right? Looks like it's, I don't know. I mean, I made up that triangle, so I don't know. Maybe that makes sense, maybe that doesn't. We'll have to see after I pull out my triangles, after I figure out what my angle is. So 8.67 is what I think that angle is based upon my math. Now let's figure out what the angle of angle P here is. Okay, figuring out. Well, so let's solve for a cosine of. Let's figure out a cosine of one of these other angles here. All right, so the cosine of length P. Okay, so let's solve one of these. We'll say P. I'm going to say P squared. P squared is going to be equal to D squared plus F squared minus 2D and F times the cosine of P. Okay, now we have to rearrange and solve for the cosine of P. All right, so we got to take all of these things and put them on this side just by adding it to both sides or subtracting it from both sides. So P squared minus D squared minus F squared equals negative 2df cosine of P. Okay, now I'm going to multiply both sides by negative 2df. So I'm going to go I'm going to divide it by negative 2df. That turns it into that. Okay. So all my positives on the top turned into negative, and all my negatives turned into positive, and I put negative 2df on the bottom. Okay, and that gives me cosine of P on the top. All right, and then I will plug and chug here. Well, if I'm a square anything, it turns into positive. pause this for a second. I